Hello everyone. So once again I welcome you all to the course on manufacturing methods. So we are going to start the second part of module 2. So module 2 was basically for about metal forming and press working processes. So part B of this module 2 is about the rolling process. Okay. So now from our previous knowledge we already have known about the classification of your different forming processes. So there we have seen that metal forming basically it can be categorized under bulk deformation processes and sheet metal working processes. So under bulk deformation process we have already seen so how the surface area to volume, so all those things are there. Okay, those responsible the characteristics are there. So now under that bulk deformation process we have discussed about rolling process, forging process, extrusion process, etc. So this rolling process which we are going to discuss in detail in this particular part. So this particular rolling process, it's a definitely is a part of your metal forming process itself. Okay, and to be more specific, it falls under the bulk deformation process. That means in this particular case, like from the whatever is the raw material we have. Okay, so from there, so drastic change in shape, etc., size, shape, that kind of like bulk deformation will be there. Okay, so how can we define this particular rolling process, or what is this rolling process, or you can say what are the characteristics of this particular rolling process. So now rolling process can be defined as a deformation process in which the thickness of the work, that is the workpiece we are talking about, thickness of the work is reduced by compressive forces which are being exerted by two opposing rotary lobes, which is known as the rolls in our case. Okay, and what is important is the force is exerted by two rolls. Okay, and they are moving in two opposite directions. So that means if we are talking about two rolls like this, okay, so like one of the roll is moving like this, then the other roll will be moving like this. Okay, and in between we'll be working on this particular method. Okay, and this particular roll is like this, another roll is like this, and later on at the outlet we will get the particular part, okay, with a reduced cross section. Okay, so that means we will be having a particular work part. Okay, on that we will be compressing it. Okay, that's a kind of deformation process. We are going to deform it. Okay, and we are going to compress it. So the thickness we are going to reduce by the compressive force which is being exerted by two rotary lobes. Okay, so these are the two opposing rotary lobes. So one is moving, if it one is moving in this direction, another is moving in this direction, and thus this coming. Okay, so now these two rolls, okay, these two rolls they rotate to pull, and in that particular case simultaneously it squeeze the work between them, and it can produce the desired cross-sectional area. Okay, so this particular process, this rolling process, mostly you can categorize like two we can categorize in two different forms. One is the flat rolling process, just like whatever drawing I have drawn. Okay, and I have shown like two cylindrical rollers. Okay, these are basically three-dimensional if you consider. Okay, then it will be kind of three cylindrical rollers. But if we look at this particular side view only, then the rollers it will look like this kind of circle. Okay, so basically it can be flat rolling process, or we may have shape rolling, also known as the form rolling process. So how can we distinguish about flat rolling and form rolling? We will be discussing in details in the subsequent section. But the flat rolling process is the one where basically the roller that we generally use is kind of cylindrical, and there is no contour, there is no shape that is given on the roller. The roller and as a result, the whatever is the part that is processed, okay, it will be the final cross section also is kind of, it will be like the like cross section will be kind of square only, or square, or you can say rectangular only. Okay, so it's about that. Okay, that is basically practice. Similarly, we may have another rolling process whereby we can get cross section area of the final part which is a specific type. Okay, maybe some I section, or maybe H section, T section, that kind of shape. Some other shape which is where the cross section is not rectangular, so maybe this kind of cross section area, okay, which is possible, or maybe some I section, So this kind of shape we obtain by this form rolling operation or the shape rolling operation. So in that particular case, later on we will see to obtain some cross-sectional area which looks somewhat like this. So in that particular case, the rollers, okay, they must have certain contours made on that particular periphery of it. But in case of flat rolling, which is the most basic one, okay, in that particular case we don't have like any contour made on that particular cylindrical roller. So it's purely cylindrical. Okay, so now this rolling, that means it's a deformation process where the thickness of the work is reduced by compressive forces which are being exerted by two rollers which are moving in opposite direction. Okay, and generally one particular thing about this particular rolling process is the cross section area, the cross sectional area, okay, it's a constant cross sectional area throughout it. Cross section is constant through the length. Okay, so over the length, the cross sectional area of the part that is produced by rolling process is constant. So in this particular figure, we are showing schematic outlines of various flat rolling as well as shape rolling processes. So here you can very easily see, like we have shown like different uh, initial raw material. So in the form of maybe slab or billet or bloom, whichever may be the process. Okay, whatever depending on the particular like raw material shape and size. So we may work with slab, we may work with, this is a slab, we may work with billet say, okay, we may also work with bloom. So what is basically bloom? Bloom is nothing but generally it has got square cross section and 150 mm by 150 mm or larger. Okay, cross section is like this. Similarly, this slab is a kind of slab kind of thing. Okay, so it's a kind of flat is nothing but a roll form of ingot or a bloom. Okay, and or a bloom and has a rectangular cross section. Okay, this is has it has got flat has got rectangular cross section of width 250 mm or more and thickness 40 mm or more. Okay, similarly, what is billet? Generally billet is rolled from a bloom. So from bloom we get the billet by rolling operation itself. Okay, and it's built from ball, and here also it is cross sectional area is square. Generally dimension is smaller than that of your bloom. Okay, 40 mm on the side or somewhat larger. Okay, so now this slab, billet or bloom, they may be the initial shapes. Okay, initial shape of the initial material. Okay, and from this slab, billet and bloom, we by either flat rolling process, by either flat rolling process or shape rolling process, we can get a variety of different parts, or we can say products. Okay, so some of them are shown here, so we can go through it. Okay, so by hot strip rolling, maybe or we can have cold strip. Similarly, like different pipes we can have of different cross sections. Similarly, steel plates, etc., or cold drawn bars we can have. Okay, so we can have this like you can see here the rolls are kind of flat. Okay, so this is the flat rolling process. There is no, you can say, contour made on the roller, but here we can see here or here, okay, or as well as here. So you can see some contours are being made on the roller. So that means on wherever like the we can have the gap between the rollers. Okay, so that way we can have the shape. Okay, corresponding shape we can have on that particular final part. Okay, and like that. And similarly, actually we can have multiple passes of, like, it's not like in a single pass. That means if we just move it once, okay, that is known as the roll pass, single roll pass. Okay, if from the initial to the final part of that particular whatever is the work material you have. Okay, so in a particular single pass we may not obtain the final desired part. So in most of the cases multi passes are required. Okay, multiple passes are required. So in like this slide once again shown some of the other steel parts. Okay, steel products which are made in a rolling mill. So this rolling mill is nothing but the, you can say, the rolling mill is the arrangement. Okay, it's the arrangement of all the rollers and all, and in the rolling mill or through rolling mill basically we do the rolling operation. So that is known as the rolling method. Okay. So here we have shown different like intermediate steps and the final steps. Steps. Okay. So we can have this kind of like structural steps like the rail, or you can say this I section and all. Okay. So you can see like this is the cross section, right? So this is I section. So these are the rails. So we can have similarly from slab we can make different plates or sheets, or it can be rolled as coils. Similarly from billet we may make different bars, rod shape, etc., etc. Okay. So these are the intermediate steps. From here the final steps we have the sheet. Okay. So why we choose generally suppose slab to manufacture sheet? Because from slab already slab has got a particular cross section which is kind of, in this particular cases in case of billet or bloom we have rectangular cross section, but here already we have got the like not rectangular, here this is the cross like square cross section, here we have got the rectangular cross section. And now by the work of by the rolling action, so making plates or sheets from the slab, it will be somewhat easier. Similarly from this intermediate step to get bar shape or rod like shape, it will be somewhat easier. So that's why we corresponding to the final required product, we always consider the particular whatever is the particular form on which we have to work on. Okay. So now this particular figure shows different final parts. Okay. Now since this just like in the previous introductory classes we have discussed about cold working process, hot working process and all, and we have seen their advantages, disadvantages, or you can say in which of the operation, like we already know in kind of hot working processes basically what happens. So large amount of deformation is kind of it's possible because already we work at a elevated temperature and ductility present is kind of more. Okay. And so that by using kind of somewhat less pressure or less force we can get higher reduction in the or higher deformation. Ultimately in this phase of our rolling we are talking about higher reduction of cross sectional area. So in most of the cases the most of the rolling process is generally carried out by hot working process. Okay. And as it is we are talking of rolling operation, so this hot working in case of rolling is nothing but hot rolling. Okay. And why we generally do, because we have to go for large amount of deformation that is required. Okay. And as in the case of hot working processes, so hot roll methods they are generally free of residual stresses and isotropic, the properties are isotropic in nature. Similarly, some of the advantages, disadvantages are also associated with the hot rolling process, just like in the case of hot working process. So here also close tolerance of dimensional control, it is somewhat difficult. As well as during the hot rolling process, there is a prone oxidation scaling. Okay, it is prone to oxidation scaling. Okay. And similarly, just like in the case of hot rolling, we also perform cold rolling operation also. Okay, that is also possible. And in most of the cases, cold rolling operation, when we generally process in case of cold rolling operation, generally from a particular shape, already whatever we have said, from there to achieve at the final shape. Okay, final shape, we generally go for cold rolling process. And in the case of cold rolling process, some of the disadvantages of hot rolling process, those are eliminated. So similar, the surface finish that we achieve in case of cold rolling process, it's better compared to your hot rolling process. Okay. So this is about the different parts that is manufactured by cold rolling process. Now all this time we are talking about this flat rolling. We have discussed that there is shape rolling. Okay, shape rolling operation, there is split rolling operation. So now out of this flat rolling operation and shape rolling operation, okay, so basically the basic one is the flat rolling operation. Okay. And we'll be discussing most of the cases with the flat rolling operation. Later on we'll discuss about the shape rolling or form rolling operation, whereby we will see how can we achieve different geometrical shapes, cross section of different geometrical shapes apart from rectangular or square kind of cross section in this particular case. Okay. So now in this particular slide we are discussing about the flat rolling operation. We are representing flat rolling. Okay. So now what is this flat rolling? So this is a flat rolling is nothing but the basic version of your rolling operation. So whatever directly comes into your mind whenever we are talking of rolling operation is nothing but the flat rolling. So like for in layman's term, one of the, I can say, uh, an example that can be considered as one of the very basic example of rolling process is nothing but the rolling of chapati or roti. Okay, maybe all of you have already seen how we make, or your like mother makes roti. Yes, the chapati. Okay, so what basically is there, the initial dough we will be having, which is having a particular thickness, higher thick, and now we have the belan or the roller, which generally maybe sometimes you have been hit while you are making, like sometimes you are not studying, or you are playing too much or like that. Okay, and maybe some, because of your misfortune, maybe sometimes you have been hit by that particular one type of roller known as the belan in India. Okay, so that particular thing, that belan is nothing but the, that nothing but the, you can consider like a roller. Okay, flat roller. So you can visualize that particular, you can say, I think that roll, right, that belan. Okay, so what is there? Okay, that particular stick kind of thing, it's a kind of cylindrical arrangement that we have. And what we generally do, so that initial dough we will be having. Okay, and now what we generally do, will in that particular case, that's like only one single belan that we have, we hold it, and we actually press gently on that particular dough. Okay, and we roll that particular roll, right? So because of that, and because we are applying pressure, and in beneath it we have all that particular surface. Okay, that means some pressure, friction, like all those things are involved. Okay, and in that particular case, when you roll it, basically what happens, we are making the roti flatten. Okay, so initially whatever is the dough, okay, it has we had, okay, the volume was there. Okay, whatever constant volume. Okay, so after that, what is basically happening, it gets flattened. Okay, the surface area is kind of more. Okay, it gets spread, and along with that, what basically happens, the thickness of it reduces. Okay, so that that particular basic thing which our, like our in our household, our mother is always doing and all. Okay, so that's nothing but kind of, can consider a type of rolling process. Okay, flat rolling process, where the the roll, that is nothing but the cylindrical roll that we have. Okay, if you look from side view, okay, that will look like a kind of circle. Okay, so it's something like that. Okay, so in that particular case, what was happening, so actually, if initially your dough is of this particular thickness, you can consider, then once we have that particular roller, you roll it, we are applying some particular pressure, your mother is rolling it, so basically it is getting flattened. Yes, so the thickness is getting reduced. Okay, and in the meantime, if previously this was the size of this particular dough, okay, now maybe in the next run it has become like this. Yes, correct or not? So but in that particular case, whatever is the thickness that we had previously, okay, so from there we'll get some other different thickness, and this particular final thickness is less than that of this particular thickness, initial thickness, right? So similar in the case of our rolling process, here also the final thickness will be there, and initial thickness that is already there, which will be different. And now just consider once again, the come back to your making of roti. So in that particular case also, is the final set or the final required thickness of that particular roti, is it in a single pass of the belan? Definitely not. So here also in practice, generally, so whatever is the final record cross section, okay, which we record after the rolling process is over, that generally is not obtained in a single go. Okay, there will be number of similar operations that will be involved. Okay, number of passes will be involved. So generally, number of passes are involved so as to obtain the final desired thickness. Okay, so now how basically it's working. Okay, so now we already know this rolling process, it produces components having constant cross sectional throughout the length. And apart from that, we know, like by using shape rolling and all, okay, shape rolling or form rolling, we can produce shapes like I section, T section, L section, or channel section, etc. Okay, but in general, by the help of this rolling process, very complex shapes, okay, these are, we don't go for it. Okay, like simple this I section, T section, these things are possible. Generally these things are possible, but we generally don't go for very complexes. Okay. Now what basically happens, so we'll be going back to the previous once again previous slide. Okay, so the here also we have discussed about, we have represented the flat rolling process only. Okay, now you can see we have the particular work method. Okay, and on that basically we make compressive force, we apply a compressive force by the help of two rollers. Right now we are talking of flat roller. Okay, flat rolling process. That's why the contour of this particular, this is the 3D view we can consider. Okay, so the whole length you can see. Okay, so this is these are the two rollers. Okay, or also known as the two rolls. Okay, and one is rotating in this direction, another is rotating in the other direction. Correct. So during that particular rotational movement, as they are in contact with that particular workpiece, okay, this work material, okay, and as well as they are applying certain pressure on it. Okay, and they are rolling. So in that particular case, it's a kind of, and yes, along with that, we can see that the surface of the roll is in contact with the surface of that particular workpiece. Okay, so we already know there will be some roughness on that particular roller and all. Okay, so now during that particular movement, I believe all of you can visualize what will happen. So already we have the roughness in between. Okay, the surface and all, they are not 100% perfectly smooth. There will be some roughness involved. Okay, and because of all those things, actually what is basically happening, so whatever is the work material we have, okay, pulled it will be pulled in this particular direction, as well as we are having some pressure is being applied here. Okay, and that is going to work there. And what will happen, once from this side it is entering. Okay, this is the entry side. So from this side actually it is going to exit. Yes, this is the exit side. And now what will be the difference between the entry and the exit? Okay, so from this figure I believe all of you can visualize. That means in a three-dimensional case you can see. Okay, this is the work strip. Okay, and this is the roller. Okay, this is the whole direction, or you can say the whole length of this particular roller. Okay, and it's a, what kind of roller is this? It's a flat roller. Okay, by the help word flat roller, don't get confused as if it is like this. Don't think like that. What does it mean? Basically flat rolling. So flat rolling is with respect to the final cross section of this particular, you can say, part. Okay, so roll part. So here also in flat rolling, generally the cross section of the flat roll part, it is rectangular only. Okay, and in this particular case, so why we are getting rectangular cross section? From initial rectangular cross section we are getting rectangular, final rectangular cross section only, but some thickness of initial thickness and the final thickness, if you see, you will see that the final thickness is being reduced, correct, during the rolling process. Yes, and both the rollers, one is rotating in this direction and another is rotating in this particular direction. Okay, so the thickness of the metal, that can be drawn into the rolls, it depends on the roughness of the roll surface. Okay, so what will happen, so rougher roll, it will be able to achieve greater reduction compared to the smoother roll. Okay, and now depending on how much reduction etc that has been achieved. Okay, so now that the reduction that could be achieved with a particular given set of rolls, it is designated as the angle of bite. Okay, so here you can see, actually this angle is also known as the angle of bite. So in terms of the draft achieved, that is the reduction achieved, there also we can discuss it. Okay, the angle of bite, it basically gives us the indication about this particular reduction in the, you can say, reduction in the thickness. Okay, you can see, so initial work thickness is this much, T naught. It is moving in this particular direction with a particular velocity. Okay, there will be particular initial velocity for this particular section. Okay, initial velocity. Similarly, from this side it will be moving out, and this initial velocity or entry velocity, and the exit velocity or the final velocity v suffix f are different. And as since the area of cross section gets decreased, okay, during that particular process, all of you can very easily see, okay, the thickness gets decreased from here to here. Okay, so as that is happening, okay, the metal leaving the rolls, it will be this one, this portion is leaving, okay, this portion is entering in, and there is one portion, there will be one portion where basically both the velocities like there like pressure, later on we'll see the neutral point and neutral plane. So as this reduction process that is happening, so the metal leaving the rolls, it would be at a higher velocity than the metal which is entering here. Okay, that means if this is the velocity of initial velocity of entry, and if this is the final velocity, then the final velocity is greater than your initial velocity. Why? Because already we know from here whatever metal is entering, so here also actually we are working on the same volume. Okay, so whatever amount is entering, there is no accumulation of any material and all. Okay, so similar amount of material, similar volume is coming out, but the thing is in a reduced manner it is coming out. So in that particular case, whatever is the velocity of entry, the velocity of exit velocity is more than the velocity of initial velocity is entry. Okay, but one thing, as we already know, actually the thing is this rolling process, we know that it comes under the forming process, and in case of forming process we know that these are nothing but the constant volume processes. Generally there is no like wastage of any material and all, no elimination of material, so generally it's a kind of constant volume process. So now in that sense, the volume of the metal that enters the rolling strand, it should be same as the volume which is leaving it. But in the very initial passes, in the very initial steps, there may be some changes. Okay, there may be some losses and all. So what basically happens in the initial passes, there will be some loss in that particular thing, okay, in that particular volume, due to the filling up of voids and cavities which may be there in the initial ingot. Okay, so what may happen, as we already know, initially suppose this is on this particular thick metal we are working. Okay, and now with the help of rolls, okay, two rolls which are rotating in opposite direction, we are applying compressive force on it. And during that particular case, in the initial passes, initial steps, what may happen, so whatever some voids etc or cavities were there in between the, suppose like different grains on it. Okay, as we are applying the rolling pressure from here and here, what will happen during the reduction of cross section? Okay, so some voids will be eliminated. Okay, and because of that it will be closely packed and some volume will be lost. Okay, so in the very initial passes, there might be some loss in the velocity because of the filling up of voids and cavities in the ingot. Okay, otherwise after that generally it's a kind of constant volume process only. Okay, so now in this particular figure you can very easily see the roll speed. Definitely the rolls also will be having some peripheral velocity, the rolls. Okay, so this is t naught and v naught, these are nothing but the initial velocity and the initial thickness. So this is final thickness and final velocity. Okay, similarly if we are discussing with respect to two rolls, so this r is the roll radius. Okay, and definitely there will be some pressure, roll pressure will be there denoted by p. Okay, and this angle is known as angle of bite, angle of bite. Okay, and basically this particular angle gives us the indication about the reduction in cross section that could be achieved with a particular given set of rules. Okay, you can see this is this here it is with respect to the initial position. Okay, and this is the final reduction of thickness that is acid, okay, in this particular point, right? So this is basically this angle basically gives you the indication about how much reduction that has been achieved here, or another word is there, draft. Okay, so similarly this portion from here to here, this length is known as the contact length. Okay, so this contact length in case of roll it's basically is an arc itself. Okay, and but sometimes as we are talking of like this particular arc, okay, the size of this particular may be kind of radius may be greater. Okay, so in that particular case, so depending on the whatever is the contact length, sometimes this contact length is considered from here to here linearly also, but actually it's a contact is in the form of an arc. Okay, so in this particular figure similar kind of thing is being shown. So in the first figure actually only the one of the roller, top roller is removed. Okay, so that means here another roller is there which is like this only. Okay, and the bottom roller is shown here. Okay, so now here you can very easily see that means initial thickness h naught. Similarly we have the initial width of the material like w naught, and v naught is the initial velocity of it. Okay, this is the strip on which we are working on. Okay, and this is the bottom roller, and we have one top roller here. We should have one top roller here like this, but in this particular figure it is removed. Okay, now and like after that particular process is over, what basically is happening, so because of the compressive force that is there, actually this thickness of this particular metal strip it decreases. Now the final thickness is h final. Okay, and in the meantime actually the width of the final part also is somewhat different. Okay, then I did the width is final width is somewhat more because it gets flattened like this. It is exaggerated, but actually the material flows laterally also. In the lateral direction also material will be flowing as well as in this particular direction. Okay, so similarly second figure it shows the friction forces acting on the strip surface. So once again this is the velocity that we are showing. Okay, so this is what basically like here the bottom roll is removed, only the top roll is being shown. Okay, so there is like this is the where the roll makes the initial contact with the work strip, that is the entry zone. It's the start of the entry zone, and where the contact is broken, that basically is the exit zone. Okay, and in between this is the roll gap. We can consider like this. Okay, similarly this is the have already discussed about the angle of pipe. So initial the contact point and where the contact is broken. This is the contact starting of contact, breakage of contact. Okay, so this angle is at the center is the angle of pipe. So this also gives you the indication about the reduction effect. So similarly in that particular case actually the pressure will build up during the course of action. Okay, because of the friction and all frictional force, actually what is basically happening is, so that is responsible for pulling the particular metal inside the roll, as well as how much is the amount of metal thickness we can the roll can pull, that also is the friction is responsible for that also. Okay, and in that particular case this definitely the frictional forces will be generated, and we already know the frictional force it acts in a direction opposite to the movement of it. Okay, so that is the thing. And similarly there will be like some force the pressure will be like generated. Okay, and the peak pressure will later on we'll see how the pressure variation is there in the from entry to exit zone. Okay, we'll see about that variation also. We'll later on see that actually pressure gradually builds up, and there is a point where actually pressure is the maximum pressure we get, and that is nothing but the no slip point. Okay, and after that once again it is reduced. Okay, so that is about it. And similarly this particular third figure it shows the roll forces, okay, on that particular thing. Okay, because once again there will be some can say as we are applying some force on that particular strip to reduce the cross-sectional area of it, so there will be some reaction force also will be involved. Okay, so some rule separating force, later on we'll discuss about that. So some rule separating force will act on it. Okay, and as you can see from this particular figure, the width of the strip it generally increases in the rolling process. So I hope how this flat rolling process basically works, all of you have understood. Okay. So in the next class, next volume we'll be discussing about the frictional process in rolling, how it affects, what is how we have developed the draft and all. Okay. So thank you.